Unit 6, Day 2 notes. Today we're going to discuss more about similar triangles as well as parallel lines and their proportional parts. This first example has two similar triangles, and it wants us to solve for x. In order to solve for x, we need to develop the correct proportion. In order to identify what that correct proportion is, we're going to need to know what sides are corresponding to one another. So let's identify some congruent angles first. I do recognize that these two triangles form a vertical pair. So let's go ahead and mark that congruent first. So these two angles will be congruent. Also, I realize that these two lines, the one labeled 4 and 5, are parallel. So there's going to be some alternate interior angles that I can mark as congruent. So let's mark those real quickly. So the alternate interior are the ones on the opposite sides of the line. So this one is alternate from this one. So this side with the 15 on it and the x plus 5, that is the transversal piece. All right, so now that helps because I know that 15 is between the single red angle and the double green angle. So it's going to correspond to x plus 5 because it's in the same position. So I can set up my proportion now using that information. So 15 is proportional with x plus 5, and also 4 is proportional with 5. But make sure you put it in the correct spot. So since 15 was on top, we'll have to put 5 on top because it's from the same triangle. And then that means 4 would have to go on the bottom. So there is a correct placement for this proportion, so be careful. So notice, again, everything that came from the right triangle, right here, I put at the top of my proportion. I could have put everything from the right side in one fraction, which is also another way to do this. What I'm saying is I could have done a proportion as like this. I could have done 15 is to 5 as x plus 5 is to 4. This would also work. Just be careful, okay? There are several different ways to do this, but there's only a few that are correct. Anywho, let's go ahead and solve the one on the left. Doesn't matter which one I pick because they'll give me the same answer. So cross multiply, so that's 5 times x plus 5 equals 4 times 15. You must distribute the 5 on the left, so that would give me 5x plus 25, and 4 times 15 is 60. Now you would subtract 25 from both sides, which would give you 5x is equal to 35. Yes. And now divide both sides by 5, so x is equal to 7. So essentially, identify your proportional pieces, set up the proportion, and then cross multiply. Now we're going to talk about parallel lines and the triangle proportionality theorem. It says, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So what it's referring to is line BE on this illustration. BE is proportional to CD. I'm sorry, it's parallel to CD. And BE is intersecting the other two sides of the triangle, AC and AD. So what it is telling you is that AB is proportional to BC, and then AE is proportional to ED. So because that theorem is true, you're welcome to use that theorem in certain situations. It may not work in every situation. Another proportion that you could set up from the same information is to take AB over AE, because if you look at it, they're both on the left side of the green line. And then you could put BC over ED. So you could do either one of those setups in this scenario to get your answer. And they would both work. All right, number 2 gives us some information, so let's label it on the picture. RQ is 8. RS is 6. UT is 9. And they want us to find the length of QU. So we don't know what it is, so let's give it a variable. You should notice that RU is parallel to ST because of the arrows. So since we have all the proportional parts, we can set up our proportions. I could say QR is to RS as QU is to UT. Or I could say QR is to QU as RS is to UT. So those are your two options in this scenario, and it doesn't matter which one you decide. So here's QR. And QU, they're both at the top. So you can put them both at the top or put them one on top of the other. And then you had RS and UT. You either put them both at the bottom or one on top of the other. Those are your options. All right, so now that I know how the proportion is going to be set up, I'll insert the values for each of those segments. QR being 8, RS being 6, QU being X, UT being 9. Or again, I could have said 8 is to X as 6 is to 9. You're going to get the same results. So now we cross multiply. You will have 6x is equal to 72. Divide by 6. And x is equal to 12. In other words, QU is equal to 12. Now the parallel lines doesn't just work for triangles. As you can see in this setup, it's not triangles, but you still have proportional parts. I will highlight the proportional parts. This part is proportional to this part. And this part with this one. So now you can write your fractions. Either put yellow over yellow or green over green. In other words, x over 210 is to 120 over 140. Or x over 120 is equal to 210 over 140. Those are your options. Let's finish this problem. With practice, you'll be able to pick up on some of these proportions yourself, and you're going to have to before test day. All right, on number 4, it tells us that xm is 4. So let's label that. Xn is 6. Nz is 9. And they want us to find xy. So you should realize that xy is this entire side up here. We don't know what it is, so we're going to call it x. We're missing my. If we knew what my was, we could use the setups from the previous 2 examples. But since we don't, the best method in this scenario is to separate the triangles. So separate the 2 similar triangles, which would be xmn with xyz. So again, since these are parallel, you have some congruent angles. And it probably works best to have the congruent angles marked and in the same location when you separate the triangles. So x will be congruent no matter what because both triangles share x, right? And then n is in the corresponding position with z. So those are congruent. They're corresponding because corresponding parallel lines, transversal. Remember this information from a couple units ago? Yes. So there you go. So it's probably best to keep them all in the set up and arranged the same. It's very helpful, trust me. And then once you have the angles marked, go ahead and label the sides with the appropriate information. So xm again was 4, xn was 6. Now, it doesn't exactly tell us the distance from x to z, but you can find it because you simply just need to add 6 and 9 and you get 15. And then again, we're looking for xy, so let's call that x. So now you should be able to clearly see what sides are proportional. What sides are in the same position or marked the same. So we now should be able to see that xm is proportional with xy, and also xn is proportional with xz. So that's one setup, or you could say xm is to xn as xy is to xz. Those are your options for this scenario. So for every situation, There's 4 correct ways of doing this, but I only show you 2. There's no point to show you the rest. Now fill in the information. So that's 4 over x equals 6 over 15, or 4 over 6 is equal to x over 15. Those are your options. And now you should be able to finish and find xy, which is x. On number 5, I'll label the information and we'll see if we got to separate this triangle or leave it intact. It depends. It tells us CE is t minus 2. EB is t plus 1. CD is 2. And the distance from C to A is 10. So this total distance is 10. So you have 2 options. Can you find that missing part, 80? Of course you can. Take 10 minus 8. 10 minus 2, and you'll get 8. So now you could do part over part equals part over part. So I'll highlight the parts that will work, and you need to finish the problem. So these 2 parts are proportional, the green ones. And these 2 parts are proportional. So now you can finish the problem. Find T and find CE. And our last example, and we're almost done, folks. Now on this one, it's a little tricky. As you can see, we're not given RU and UT, so we can't do part equals part. We have no choice in this scenario but to separate the triangles. I'm sorry. So let's do that. First, by identifying the congruent angles. So we know T is automatically going to be congruent. And then R corresponds to U. So again, when you draw your 2 triangles separate, put those angles that are corresponding in the same area. So the big triangle is RST. The little triangle is UVT. Now we label the information as they have on our picture. The small triangle is easiest first. So UV is 6, VT is x plus 2. SR is 14. And now we have to find ST. We find ST by combining these 2 segments. So you have to add these 2 segments together. So 3x and x will make 4x. Negative 3 and positive 2 will give you a negative 1. So when you combine both those pieces, you have 4x minus 1. And now we can write our proportions. We would say SR is to VU as ST is to VT, or you could say SR is to ST as VU is to VT. So now that we know that information, we can fill in with the correct values for each piece. SR being 14, VU being 6, ST is 4x minus 1, and VT is x plus 2. Or you could do the second one, but either one is fine. So now you can find the value of x. I also want to take a sidebar real quick and explain what a similarity statement is, because you're going to be asked about this in your future. So a similarity statement is when you say one triangle is similar to another. So using this example, I would say triangle or I could say triangle SRT is similar to triangle VUT. Notice I put the angles that are congruent in the right locations. And that's all a similarity statement is. You're just naming the triangle, but make sure you name it with the appropriate angles in the correct spots. This concludes your notes for today. Make sure you finish the examples I did not, as you're going to be expected to know how to do them.